So in this video, we're going to talk about the determination of boiling points and melting points of organic compounds. Right, so this is one of the first labs that you guys will actually do in organic chemistry, specifically for organic chemistry 1. And typically at undergraduate level, you should expect some compounds like these to be present. So you may have compounds such as methanol. This is methanol. You may have even ethanol, maybe 95% ethanol. You may have 1-propanol as well. So these are all liquid. And usually your professor will have these labeled for you, right? But these are some of the compounds that you should expect. This is a solid and liquid lab. So you should expect solid compounds such as cinnamic acid. All right, this is cinnamic acid. You should also expect compounds such as naphthalene. So these are common, I mean, really across the US, even in other countries. But this lab is pretty much common in organic chemistry. And there's other compounds such as benzoic acid, 1-butanol, etc. Now, before you do this lab, you want to make sure you actually know the info on some of the compounds that you guys will be working with. So in the lab manual, they're going to give you the compounds, and you should be expected, if not provided, you should expect to know obviously the name of the compound, the molecular weight, the density, the melting point, the boiling point. So let's do an example for or liquid, right? So obviously there's a bunch of liquids. I'm just going to do one example, and let's say we're going to do methanol, right? So the name for this liquid is methanol. The density is about 0.791 grams per milliliter. The melting point is actually negative 97.6 degrees C. And the boiling point is actually 65 degrees C. So these are some of the physical properties that you should expect to know for this lab. An example of a solid may be benzoic acid. And you must know the density, right? So the density of benzoic acid is about 1.32 grams per milliliter. The boiling point is about 249.2 degrees C, and the melting point ranges from about 121 to 122 degrees C. Now, one thing I forgot to mention for all of these, which is very important, is molecular weight, right? So the molecular weight for benzoic acid is about 122.1 grams per mole. And the molecular weight for methanol is about 32.04 grams per mole. All right, so these are some of the background information that you should know before entering the lab. The safety hazards, right? So you want to make sure you know any safety hazards with any compounds you're working with, right? So for example, if you look at any safety hazards for this lab, you may expect for something like ethanol, you'd expect it to be highly flammable, You may expect it to be highly flammable. It may be absorbed into the skin, right? So these are some of the cautions that you want to know about the compound. So it may be absorbed into the skin, etc. Reacts violently with oxygen or with oxidants. I'm sorry, right? So these are some of the safety hazards that you must know about the lab itself. So let's talk about the procedure. So this lab is pretty much identification of an unknown, right? So you're given a solid. Your professor is going to give you a solid sample and a liquid sample. So that's going to correspond to about two data tables, right? So let's say this is our data that we're looking at. So we're going to do the solid first. I'm sorry, the liquid first. And obviously, professor is going to provide you with a sample number. You do not know what that sample is. It's an unknown. So let's say you're given sample E. It's usually a vial. Now, because you want to identify the unknowns, in this case it's a liquid, sample E, let's say, we're going to use distillation. So the first thing you want to do before and I have a video that kind of discuss how do you set up a simple distillation. So the first thing you want to do before distillation is measure the volume before distillation. Right? So I'm going to go with some numbers that I did when I was in organic chemistry. So the volume I received for before distillation, I measured, you have to measure, and I measured it to be 15 milliliters. Now, you must know what the receiving flask weighs, right? So you must get the weight of the receiving flask. That means the flask that is actually getting the distilled liquid inside it. When I was doing this experiment, mine came out to be 23.4270 grams. Now, with measuring that empty receiving flask, you must measure the flask or that receiving flask plus the liquid. So the flask plus the liquid you got back, I measured to be about 34.3040 grams. Now, what about the volume recovered? You must measure the volume recovered. And this is actually something we actually calculate. And I'm going to get to this in a minute. The volume recovery is usually in milliliters. We're going to leave that blank for a minute. How about the mass recovered? That's going to be in grams, and we're going to leave that for calculation purposes. We also need to fill out what is the expected boiling point of the compound and what is the experimental boiling point. So the expected boiling point, and that's in degrees C, and the experimental boiling point, that's also in degrees C. Now the experimental is what we do in the lab. The expected is the theoretical value. What about the unknown name? All right, so this is after we have gained so we can name the unknown in the sample vial after we've gained the melting point. We're going to also calculate the percent recovery, and that's in a percentage units, obviously, and then the density. What is the density of the liquid or the unknown that we are talking about? So how do we go about actually calculating the first thing, which is the mass recovered? Well, the mass recovered is simply the difference between the receiving flask, or in other words, the mass recovered is the flask plus the liquid minus the receiving flask. So if you plug 23, so if you plug 34.3040 grams minus 23.4270 grams, that is actually the mass recovered. And so this would actually be 10.8770 grams. We're going to talk about the volume recovered in a minute after we've actually gained the density. Now, what is the volume recovered? Well, this is an experimental value that we have to get or measure after. This is an experimental value that we measure after we get the volume in the flask, right? So we get the mass of the substance in the flask, and that is the mass recovered. So we could do this. We could do this two ways. We could actually measure the volume, maybe in like a graduated cylinder, or we can actually use the density. But since we do not know the density, this is simply just a measurement in a graduated cylinder. And when I did my measurement, my volume recovered in the flask was about 14.95 milliliters. Now, the better way to do this is what we're thinking. So, my experimental, based on your knowns, what is the experimental boiling point that I got? The experimental boiling point that I got was 64 degrees C. Now, based on the compounds that you're working with, you have to look at the boiling points of the liquids and see which one is closest to that 64. Now, out of all my compounds, ethanol was the closest, and so its theoretical boiling point was actually 65 degrees C. Why did I put percentage? Right? It was 65 degrees C. Now, based off that, because I know that my unknown now is actually methanol. Right? So that's how you figure out your unknown in the lab. Now, let's go back to this volume recovery, because the way I did it, do not make my mistake, is not how a chemist calculate the volume recovery. So you typically do not want to weigh out stuff, right? Now that we know what type of compound we're dealing with, which is ethanol, and let me put in my units, even though my units are already there. Now that I know that I'm dealing with methanol, I could simply look up the density. And I know the density of methanol. Is, and let me go back to the data that I have in my lab, right? But this is stuff that you actually already know. And so if you know the density of methanol, in this case, I have the density to be 0.791 for its theoretical value, then I could simply take the density from my mass recovered. So I could take the mass recovered, which is going to be in grams, and I could multiply that by my density, which in this case I will flip from grams per milliliter to now milliliter over grams, and this is essentially milliliters, right? So that's another way. The whole point of me saying this is another way of calculating your volume recovered. But again, I just measured the volume recovered. If your professor typically don't care, this is something you could just measure. If they're pretty particular about it, then you could just use the density if you already kind of suspect what compound you have. All right, so now that what I get for the boiling point was 64 degrees C, the expected boiling point for the compound, or the theoretical value, is 65 degrees C. So I know that I'm dealing with methanol. For my percent recovery, that is simply just the volume recovered. To calculate the percent of recovery, that's simply just the volume recovered over the volume of liquid before distillation. So this is the volume before distillation. All right, so that's why it was important to measure the volume before distillation. And since it's a percent, we actually just multiply this by 100%. So based off my calculation, and you could go back in my lab, in my notes, you could see that the volume before distillation was 15 milliliters. And then the volume recovered was 14.95 milliliters. Right? So that's simply just dividing these two. Right? So if I take 14.95 milliliters divided by 15.00 milliliters times 100%, I get my percent recovery to be 99.67%. How about the density? To calculate the density, that's simply just the grams over the volume that you recovered. So going back to my table, the mass recovered was 10.8770. 770 grams divided by the volume recovered, which was 14.95 milliliters. If I divide that, I get 0.728 grams per milliliter. And that would be my density. That would be my experimental density, which is pretty close to the theoretical value of 0.791. So that is how you would fill out that table for your liquid section of the experiment. For the solid, let's label this. So this was for the liquid section. So this is data for liquid. And let's look at the data for the solid. Again, this is the solid flask that you got is an unknown, right? So let's say you have a sample number, and let's say this is the same sample, E, but it's in a solid form. You're simply just going to take a melting point using any melting point apparatus at this point. So in this case, you may have an expected melting point and an experimental, which was what you measure, melting point. When I did this lab, the experimental melting point was about 81 to 83 degrees C. I then took this value and look at the compounds and look at the expected melting points. And the expected melting point of this compound is closest to my experimental, and it was 80 to 82 degrees C. So then in the chart, you need to figure out what the unknown name is. And in this case, my compound was naphthalene, right? So you do the same thing for your compound. Now, there's one thing I want to point out. Usually, your experimental melting point should never be higher than your theoretical melting point. That usually happens if you have some sort of contamination. But in my case, my experimental was about 81 to 83, so it was slightly just above 82, but it's not enough to be alarmed about. There's some impurity in the sample. So based off that, I figured out that my compound was naphthalene. Now, in the last data table is is a mixture, is what you actually want to do to confirm for sure that you have what you say you have, right? So it's pretty much to confirm that you have what you say you have. And this is something you usually do with solids. I mean, you could do it with liquid as well, but usually a distillation will really tell you what you have. All right. So the idea here in your third data table is you're gonna take your unknown plus the unknown suspected. So the unknown suspected is what you suspect, and this is really we're looking at here. We're really looking at um, solids. Again, you could do this for liquids, but your professor will pretty much most likely let you do this for solids only. So say for example, and I'm gonna do this in my case. So when I did the experiment, my suspected unknown was naphthalene. So I'm gonna take some. It doesn't matter. It doesn't matter how much. I usually want to take a little bit, but it doesn't matter how many you weigh out. So I'm gonna take my unknown that I suspected, which was naphthalene, and I'm gonna mix it with the same unknown that I think it is. So I'm gonna take my unknown, and they usually have this labeled in the lab. So it's gonna be a purified sample. So let's say that I have an unknown, and let's say I think my unknown is naphthalene. I'm going to take my unknown and then mix it with the same compound that I think it is, which is naphthalene. So this is essentially naphthalene and naphthalene. And the reason why you do this is that you want to take the melting point. So you want to take the unknown plus the unknown suspected. You want to take the melting point. When I did this experiment, mine was about 81.5 to 84 degrees C. Now, here's the reason why you do this. It's to confirm that you actually have naphthalene. Now, if you have, let's say you took naphthalene and you mixed it with cinnamic acid, your boiling point is actually going to be higher than what you suspect, right? Because it's some sort of contamination within the product. So it will pretty much confirm to you that, okay, well, maybe I really do not have naphthalene. So this is the reason why you mix the two, your suspected and your unknown together. And then what they'll typically ask you to do is take your unknown and mix it with a different compound. So you're going to take your unknown plus mixture of different compound, and you're going to take the melting point. Now, let's do the melting point in the next section. But essentially, my thing was I took naphthalene, which is what I suspected, which was my unknown, and I mixed it with acetamide, or not acetamide, but acetanilide. Right? So this one I hate saying, but it is acetanilide. Right? And then I take then I took the melting point of this mixture, and I actually got 82 degrees C to 87. So that was the melting range. So you can see that it is way higher than mixing both naphthalene and naphthalene. And I took my unknown again. So you actually do this twice. I took my unknown plus the mixture of a different compound, another one, so not acetanilide, right, but rather I use this time methyl M nitro, right? So I use actually methyl M nitrobenzene. So this is methyl M nitrobenzene. So I took naphthalene plus methyl M nitrobenzene. And the melting point for this mixture ended up being about 85 to 91 degrees C. So what these numbers are actually telling you is that when I mix my compound, my unknown, with naphthalene, which is what I suspected it to be, the melting point did not really change from the experimental value or the expected value. Whereas when I contaminated my unknown with something like acetanilide or methyl M nitrobenzene, you notice that the melting point actually drastically increased. That means that I'm mixing my unknown with some sort of contaminant. So this is the last data table that your professor will usually ask you to do to confirm that you actually have the solid that you do say you have. And those were the calculations of the lab. So it's pretty much a simple lab, kind of one of the first labs you'll do in organic chemistry to kind of introduce you to the idea of distillation.